Hello friends, welcome to Susan and John MathTube. In this video, we continue our discussion in reduction formulae and we are going to do something very interesting. So the question goes like this: evaluate the integral cos to the power mx multiplied by sin n into x. So here you can see we have a product where m is on the power and n is a multiple. Okay, and there is one more question. Hence evaluate integral 0 to pi by 2 cos to the power mx sin nx dx. Okay, so let's give it a try. So look at this. I think you can see we have two quantities here, m and n. So we start with the integral name m comma n. We call it I m comma n. So here we have cos to the power m and sin nx dx. Okay, so for those who have problem with integration by parts, I will do a few things here on one corner. Do you know how to differentiate cos to the power mx? You can imagine cos to the power mx to be cos x the whole power m, so that its differentiation will be, it looks like something to the power m, kind of like the formula x power m. So the answer becomes m into same thing the whole power m minus 1 times the derivative of cos x, that is minus sin x. So remember, this is how we differentiate cos x the whole power m. By the way, when you write your answer in your exam, we never write this as cos x the whole power m, but we write cos to the power m x or cos x to the power m. So we will write the answer. Okay, now for those who do not know, what is integration of the second function? Anyone? It is minus cos nx the whole divided by n. Okay, now ready to start. Let's start with integration by parts. So we have the first function multiplied by integration of the second function minus inside an integral the derivative. The derivative is already here. We can see there is one more minus. Anyway, we will copy it as such first, and the integration, now let's write it a little bit bigger. Now minus will be minus, m by n comes outside, cos to the power m minus 1x cos nx sin x. Okay, now listen very carefully. How did you name the given integral? How did you name the given integral? The given integral was given the name I m comma n. Now I told you long back, this is the 5th lesson in reduction formula. In the first lesson itself I told you, when you derive a recursion formula or a reduction formula, you will always write the bigger number in terms of the smaller number. So basically this is what we expect. We want cos to the power m minus 1 sin n minus 1. This is what we want. I'll make it a little bit clear. So look at this. When we reduce it, we want n to become n minus 1. M to become m minus 1. and that name will be m minus 1 comma n minus 1. Is that okay? So once more, look at this. Who will be cos to the power m minus 1 into x sine n minus 1 into x dx? Yeah, this will be our I m minus 1 comma n minus 1. So did you notice the second character, sine n minus 1 into x? And did you notice the first character, cos to the power m minus 1? Okay, now listen very carefully. At least we got cos to the power m minus 1. But we did not get sine n minus 1, right? So we have an awesome trick. So what I am going to do is, since we did not get the second part reduced into sine n minus 1 into x, I am going to make an inspection. I want to know who is this sine n minus 1 into x. Actually, sine n minus 1 into x after distribution becomes nx minus x. Come on, think about it. That is, sine n minus 1 is x is actually sine, I think you know the formula, sine a minus b, sine a cos b minus cos a sine b. Wait a minute, I saw this somewhere. Oh, these two are actually same. I have an idea. Anyway, we need sine n minus 1 into x. So I have an idea. What I'm going to do is, I'm going to replace cos nx into sine x with the remaining quantity. That means I'm going to take this to the left and this quantity to the right. So I'll get sine nx cos x minus sine n minus 1 into x. So look at this, I'm going to replace this. What should I write here? Sine nx cos x. Now let's distribute it. Okay, let me ask you one question. What is a power m into a power n? Isn't it a to the power m plus n? So when you distribute this, I hope you can see that cos to the power mx will be formed and sine nx, and cos to the power m minus 1 into x, sine n minus 1 into x. Anyway, I am going to distribute this integral now itself. Why to waste time? Dx, dx. And that's it. You can be very happy because we are almost near our reduction formula. Can you recognize the first integral? Oh, that's exactly our question. See, cos to the power sine multiple. Now look at the second one. M got replaced with m minus 1. N got replaced with, we actually did it forcefully, but still we are successful. So this is I m comma n minus I m minus 1 comma n minus 1. Well, it looks like a reduction formula, but I am not going to call this a reduction formula because the bigger number should be completely in terms of the smaller number. And I know it's not a big deal. You can distribute this and you can take that I m comma n to the left side, and on the right side I'm skipping steps, plus, because when you distribute you'll get m by n. Now what is common? Take LCM. So you're going to get it cancelled. So I m comma n is equal to, well, that's it. Okay, now we got the reduction formula, so let's put it inside a box. Okay, now let's go for the second question. It was hence prove that. Oh, I erased that. Okay, I'll write the second question. In the second question, what happens is they have given one limit 0 to pi by 2. Okay, so I'm going to write like this. If I m comma n is equal to integral 0 to pi by 2 cos to the power m x sin n x dx, then what will become to this reduction formula? You think about it. There won't be much difference except the fact that you had to apply upper limit minus lower limit. So I'm going to write 0 to pi by 2. Will there be any change here? No, there won't be any change. Okay. Now look at this. We have to plug in the upper limit now. What is cos 90 degree? 0. So when you plug in the upper limit, you're going to get 0 minus cos 0 is 1. 1 to the power m, 1. Cos 0, 1. That's it. There won't be any change in this part. That is, our reduction formula becomes 1 by m plus n plus m by m plus n minus 1. Now let's do one more awesome question before we wind up this video. So the question goes like this. Obtain a reduction formula for integral 0 to pi by 2 cos to the power nx cos nx dx, and prove that on simplification the value becomes pi divided by 2 power n plus 1. It's something similar to the previous problem, but we have an advantage. We don't have two alphabets here, we have only one quantity, that is n. So let's start with the naming. Let's call the given integral to be in. And the procedure is exactly the same. So we get in equal to, first function, integral of second, within the limits 0 to pi by 2, minus integral 0 to pi by 2, the differentiation. Now you know how to differentiate. I am not going to add more steps. It is in the last problem. It's also in a previous video. So here we go with the derivative, and now you have to copy this. Now can you please plug in the upper limit? What is cos 90? 0. Sin 0, 0. So that part will vanish. Now I can see that these two get cancelled, and minus will be plus. So 0 to pi by 2 cos to the power n minus 1x sin nx sin x. Wait a minute. Time to go back and check. Okay. Look at this. This is our question. Look at this very carefully. We have power n and we have multiple angle nx. So once you obtain the reduction formula, we are expecting 0 to pi by 2 cos to the power n minus 1x cos n minus 1 into x. Okay, now look at where we have reached. I can see cos to the power n minus 1 into x, but I am not able to see the second term which I showed you just now. So what's the trick? Put a box and we are going to check who is that character. Which character? Cos n minus 1 into x. Oh, that is cos nx minus x. That is cos n minus 1 into x. Okay, do you remember the formula cos a minus b? Yeah, that will be cos a cos b plus sin a sin b. Oh, wait a minute. That is exactly what we want. So, what will be our sin nx sin x? That will be cos n minus 1 into x minus cos nx cos x. So, time to replace. So, we are going to replace this with this. So, what should I write here? Cos n minus 1 into x minus cos nx cos x. So, you can open the bracket. Okay, let's cut a few steps because it's obvious we did so many problems. This will be I n minus 1 and the second one will be after simplification in. So, we get the reduction formula. This is not the reduction formula. We will take it to the other side. So, you get 2in equal to I n minus 1. That is I n is equal to 1 by 2 I n minus 1, which is the required reduction formula. And of course, the ultimate interval will be I0. You can plug it into the question and that will be cos to the power 0. That will be 1. Cos 0, that will be 1. So, you are going to get pi by 2. Okay. Now, they asked us one more question. They asked us to simplify the reduction formula and prove that the answer is pi by 2 power n minus 1. Of course, that's very easy. You have to keep in mind this reduction formula, and first we will plug in n minus 1. So, we get 1 by 2 into 1 by 2 I n minus 2, and that will be 1 by 2 into 1 by 2 into 1 by 2 I n minus 3. That will be 1 by 2 into 1 by 2 into 1 by 2 into it keeps on going till we get I0. So, the answer will be I0 we already know, we got pi by 2. So, using that logic, it is very simple, that will be pi by 2 to the power n plus 1, because there will be 2 into 2 into 2 into 2 into 2 n times and that pi by 2. So, that is how we get 2 to the power n plus 1. That's it. So, we will wind up this video here. I hope you are enjoying these videos, and I also hope you are practicing a lot of problems. Always remember, you have to practice a lot so that you can score good marks in your exam. So, I'll be back with more videos. So, till then, my friends, bye.